Alright, welcome to my law of cosines video. In this video we're going to do a brief explanation of what the law of cosines is and does, when you can use it, and then we're going to see two examples of how to use the law of cosines in order to solve for missing sides or missing angles of triangles. So let's first talk about what the law of cosines is. The law of cosines is an equation that allows us to find missing sides and angles of a triangle. So let's say I have a triangle here. I'm going to name it angle A here, angle B here, and angle C there. Now those are the angle names with capital letters. And the side lengths are going to be lowercase, and the side that is opposite angle A, so opposite over here, this is lowercase a. Over here, angle B, opposite that is this side right here, so this will be lowercase b. And finally, this angle up here is angle C, so the side opposite that is lowercase c. And what the law of cosines is going to be able to allow us to do is when we know certain pieces of information and we're trying to figure out all the pieces of information, we want to know all three angles and all three side lengths. But if we're only given certain pieces of information, we can use the law of cosines to figure out some of the other ones. And the information we are given for the law of cosines is when we know all three sides, so side, side, side. If I know side A, side B, and side C, and I know none of the angles, I can use the law of cosines to figure out what my three angles are. Also, if I know two sides and the angle between them, that's important. Two sides and the angle between them. That is the side angle side relationship from geometry. Two sides and the angle between them. If the angle is not between them, we can't use this law of cosines. That would be a law of sines problem. So if I know B, side A, and angle C, I can do law of cosines. Same thing if I know side B, side C, and angle A, I can use law of cosines. And then if I know side A and side C and angle B, I can use the law of cosines. So these are the two cases when we will be doing law of cosines work. We're going to see these cases in the examples we do today. And let's get to what the actual example or what the actual formula is. The law of cosines says that if I know, let's say we're trying to find side A. Okay, I'm trying to find side A. Well, in order to find side A, I don't know all three sides, so this would be a side angle side situation. I'm going to circle the ones we do know. We do know angle B or side B. We do know side C, and we're going to say that we know angle A right here. The law of cosines is a squared equals, okay, so A being this side, a squared equals B squared plus C squared. And you might be thinking, oh, this looks very similar to the Pythagorean theorem. And you'd be correct. It is starting off as the Pythagorean theorem. But remember, Pythagorean theorem is for right triangles. So there's going to be a little bit added on to this. We got a squared equals b squared plus c squared minus 2 times b times c. So we take these two lengths, b and c, we multiply them together, and we multiply them by 2. We double them. And then for the final part, times the cosine of the angle that we have. So cosine of A. This is your law of cosines. And we can recreate this for every angle here. This is when we know the two sides that are flanking angle A, or that are creating angle A. Okay, if I wanted to, I could create one for B or for C. So let's try that. If I have, hold on, let's erase my little green circles this time. I have to fix those. Okay, let's say this time I want to know side B, lowercase b here. Okay, that would mean I would have to know side A, side C, and angle B. Well, why don't you pause the video and give this a try. See if you can create the new formula. I'm going to leave this one here because this is when we're looking for A, but what would the formula look like if we were looking for B? Okay, so pause the video, see if you can come up with it, see if you notice any patterns in what we have here. Alright, so I said right before you paused it, hopefully, that look for some patterns. Well, here I have A in front, and I'm ending with the cosine of A. So if I'm looking for patterns, I'm starting with a side length, and I'm ending with the opposite angle. So this one, if we're looking for B, the opposite angle is angle B. So we're going to end with the cosine of B. Okay, now B is squared, and what do I have here in the first one? I have A and then the two other sides that I knew. Well, this time I know A and C. So B squared must equal A squared plus C squared. And then we get to this minus part. Minus 2BC here. Well, I used B and C when I squared them, and now I'm using the original versions of them for multiplication. So minus 2AC. And there we go. There is our B version of the law of cosines. Okay, you know, we've done 2 out of the 3. We might as well do the third one as well. So let's move this up a little bit. Let's erase this little guy down here. Don't know what he's doing. And let's clean this up. So we're going to create the final version here. Oops, that should be in red. C and A. So what letter are we going to be looking for this time? Hopefully you said lowercase c. So once again, pause the video and using our first 2 versions as examples, see if you can create the version that would use the angle up here. Remembering that we would need to have B and A and angle C. Okay, so pause the video, give it a try. Okay, hopefully you came up with this. C squared equals the two sides we know, A squared plus B squared, minus 2 times, oops, let's keep the color scheme going, minus 2 times the sides that we knew, A times B, and then ending with the cosine of the angle, which is the cosine of angle C. So there we go. There's our 3 versions of the law of cosines that we're going to be using. Now we're going to get into some examples, and we're going to use these. So if you haven't written these down on a separate sheet of paper, you might want to use that or do that so that you have them easily accessible to you. So we're going to first do an example where we have side angle side, which is the easier version of these. And then we're going to do an example where we have just the 3 sides, and we need to find all the angles. So bear with me, we will work through these, and let's give it a shot. Alright, so here is the first example we are given. Okay, we have triangle ABC here again. I've already got everything labeled. I've got my 3 angles labeled with capital letters, and my 3 sides labeled with lowercase letters. And I like to set my problems up with a list over here. So here is the list of the side lengths. Notice we know A and we know C, so I'm going to circle A and C. And then we also know angle B. We only know angle B. So there's my angle there. Hopefully, by drawing those out, we can see that this is a side angle side setup. I know 2 sides and the angle between them. Now you may be saying, hey, B is supposed to be 100 degrees. I never said my drawings were going to be to scale, so let's not worry about to scale. Let's worry about the numbers that we are given. So we have a side angle side setup. So we're going to have to create a law of sines equation based off of this information. And when we have a side angle side setup, notice that I'm only missing 1 side length and 2 angles. Let's finish off the sides first. So we want to find B. We want to find B. And if you wrote it down from before, you already know what formula we're going to use. B squared equals A squared plus C squared minus 2AC times the cosine of angle B. And this formula is going to work perfectly. We're looking for B, which is right here. We know A and we know C, and then we know the angle B. Remember, if we're doing a trig function, your calculator needs to be in degrees, not in radians. If you do it in radians, you are going to get a different answer, and it is not going to be what we are looking for. So, let's populate or fill in, substitute, the variables that we know. We know A, we know C, and we know capital B. So, I've got A is 7 squared. I know C is 5, which is getting squared. We are subtracting 2 times A, which was 7, times C, which is 5. And then we've got the cosine of 100. Okay, these are being added, and all of this is equal to B squared. So really, all this is now is a calculator problem. We can simplify some of it if we wanted to by doing the work, okay? But I don't have any unknowns over here. So if I'm careful, I could type all of that into my calculator, and it would give me an answer of 86.16, just about. We're going to be rounding. So B squared equals 86.16, just about. Okay, you might think, can I just round it now? I'm going to tell you no. You should round as the very last thing you do. And since I have to take the square root, I still have something to do before rounding. So we're going to square root both sides, and then B is going to end up being about 9.3 when we round it out. So B, we just figured it out, is 9.3, and I'm updating my list. Now, I know what B is, side B. I need to find angle A and angle C, and we have options. Because I already know all 3 sides, I don't have to use the law of cosines to get A and C. I can use the law of sines. And since those formulas are simpler, that's what we're going to do with a side angle side setup. We're going to do the law of cosines first. So I'm going to say LOC, law of cosines first. Then we're going to do the law of sines to get the rest. Okay, so when you have a side angle side set up, you're going to do the law of cosines to get the third side. Then you're going to use the law of sines and the proportions to find out the other 2 angles. Okay, so give me a moment to erase this, and we're going to go into the law of sines part. Alright, so the law of sines. Remember, the law of sines is all about relating the angle being divided by its opposite side to a different angle being divided by its opposite side. So the law of sines is, let's say, the sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is equal to the sine of angle C divided by side C. That's our law of sines. So, we're not going to use all three at once. We're only going to use two of them at once. And since I know side B and angle B, I have to use this part. Okay? I'm going to use this part with A's, get an answer for A, and then I'm going to use this part with C and get an answer for C. Or we can use a little trick for that third one. So we'll see how it goes. Alright, raise your hand if you want to do A. Raise your hand if you want to do C. Remember that I can't actually see you, and you're at my mercy to choose whichever one I choose, so we're doing A. Alright, so the sine of angle A divided by A equals the sine of B divided by B. Let's fill in what we know. We don't know angle A, so that's going to stay the sine of A divided by side A. We do know side A. It's 7. So divided by 7. And now the law of sines tells us that this is going to be equal to the sine of B, and angle B is 100 degrees, divided by the side length of B, which is 9.3. Alright, there's our setup. Okay, now we're going to cross multiply, divide, and then use an inverse trig function to get our angle. So let's start by cross multiplying. Okay, 7 times the sine of 100 and the sine of A times 9.3. Let's move this up. Whoops. So I have 9.3 times the sine of A equals 7 times the sine of 100. And you most definitely could type this into your calculator and get a number, but I'm going to recommend we leave it as this because you're going to have to round when you write it down, since this is going to go on forever, and, well, we said we should round at the very end. So we can wait to do that. Now that I have it set up, I have my equation. I went from a proportion to an equation. I need to get the sine of A by itself. So let's divide both sides by 9.3. Okay, that cancels out the 9.3 over here, and we're told that the sine of A is equal to 7 times the sine of 100, all divided by 9.3. So the sine function of whatever angle we have here, this is a decimal. This decimal is the relationship of the opposite side divided by the hypotenuse. So we have the relationship, we need to know the angle. So we're going to throw an inverse sine function here. We're going to say that A equals the inverse sine of 7 sine 100 divided by 9.3. Okay? And this is the point where we get to type it into our calculator. This all can go into the calculator. Be careful with parentheses. You might need to add an extra layer of parentheses for your numerator. But if you type that all in, you should get something that is around 47.8. So we know that angle A is approximately 47.8 degrees. And there we go, we just solved our second piece. We now know angle A is 47.8 degrees. And then there was one, just missing angle C. Now we most certainly could use the law of sines again, set it up like we just did, do our proportion, cross multiply, and find angle C. But hopefully you can think of a faster way to do this. And hopefully you're realizing that, well, all three angles in our triangle have to add up to 180. I know two of them, and whatever this is has to get us to 180 degrees. So while I could use the law of sines, I don't want to. Why not make it easier for ourselves? Why not just remember that all three are going to add up to 180? So let's take away the ones that we know. 180 minus 100 minus 47.8. And this is going to give us C. And C, as it turns out, is approximately 32.2. I know that the subtraction gives us exactly 32.2, but since we had to round with 47.8, this one's going to be approximate as well. The only one we know for certain was B. So there we go. What did we do to solve this side angle side setup? We first used the law of cosines because we knew two sides and the angle between them. That allowed us to get the third side, which is what we wanted to find first. And then once I had my third side, I could use the law of sines because I knew one of the angles. That allowed me to find angle A, and then I did 180 minus angles A and B to find angle C. So there's our example for side, angle, side. Now we're going to do an example of side, 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 where we know all of the column over here and none of the column over there. Alright, here's our second and final example for this video. I have triangle DEF over here. I changed the letters this time because you need to be able to create your formula for the law of cosines with whatever triangle is given to you. It's not always going to be ABC. So I have angle D, and across from it is side D. I have angle E, and across from it is side E, lowercase. And then I have angle F up at the top, and across from it at the bottom is side F, lowercase. And this time we know all three sides. So this is a side, side, side setup. We need to find the three angles. And you might be thinking, hey, last time I knew all three sides and I could use the law of sines. Can't I just use the law of sines this time? And look what happens if you try that. Let's say we have the sine of D divided by D equals the sine of E divided by E. If I set this up, I have the sine of D divided by 6.3, and that's going to equal the sine of E divided by 10.5. And hopefully you see the problem. I need to know one of these angles. Otherwise, I have two variables, and I don't have enough information. So we are going to have to use the law of cosines to figure out one of these angles. And which one we figure out first is completely up to you. It does not matter which angle you go for first. You just have to use your little formula and make sure you use the appropriate sides and angle relationships. So, let's say we want to figure out angle D. Okay, we're going to figure out angle D. So I want to know this piece right here. Well, when we did all three formulas before, we always started off with the side opposite the angle we had. So our formula this time is going to start off with d squared equaling, and then there's going to be some stuff here, and at the end it's going to be the cosine of d. Okay, so if I want to know this angle, I got to start off with its opposite side. And then hopefully we remembered, well, it was the other two sides squared. So it equals e squared plus f squared. And then we were subtracting 2 times the product of those sides, so minus 2ef. And there is our setup. You might not feel you need to create the formula each time, but I promise you that if you create that formula each time, it is going to help you remember the formula, it's going to help you get better with the law of cosines, and it'll make these easier in the end. So we just created the law of cosines that's going to allow us to find angle D. So let's put in what we know. We know that D is 6.3, so I've got 6.3 squared equals, we know that E is 10.5, 10.5 squared, plus F, which is 12 squared, minus 2 times 10.5 times 12 times the cosine of angle D. So there's our setup. That's a lot. Okay, and we're going to need to use our calculator because I can't just throw this all in the calculator like I did last time. I don't know the angle over here. So we're going to have to use our calculator, figure out all the little pieces, and then do some algebra to get D by itself. So let's type into our calculator 6.3 squared, and we get 39.69. Move this up a little bit. So 39.69, I'm not going to round that because I don't need to right now, equals 10.5 squared, which is 110.25. Let's change the color. 110.25 plus 12 squared, which you should know is 144, minus, okay, this is 2 times 10.5, which is 21, times 12, so 21 times 12 is 252, times the cosine of D. That's a terrible C. Cosine of angle D. Our goal here is to get D alone. Well, think about what's happening. I'm saying that 39.69 is equal to 110.25 plus 144 minus 252 times the cosine of D. I have some like terms here, so I could combine those together. 39.69 equals, okay, 110.25 plus 144 is going to be 254.25 minus 252 times the cosine of D. Okay, can't combine these. These are being multiplied. Alright, so let's get this term all by itself. Since this is being multiplied, really this is just a more complicated version of something like 5 equals 3 minus 2x. Okay? If I want to solve for x, I got to get rid of this part first. And that's what we're happening here. So let's get rid of 254.25. We'll subtract that from both sides. Let's do it in blue. Minus 254.25 minus 254.25. And what do we get? 39.69 minus 254.25. And we get negative 214.56 equals negative 252 times the cosine of D. Alright, we're getting closer. Now I want to get the cosine of D by itself. So let's divide both sides by negative 252. That's going to cancel those out, and I'm going to flip it around, but I've got the cosine of d equals whatever 214.56 divided by 252 is. All right, we've come a long way. This law of cosines, when we have all three sides, is a lot more intense than the original, but it is what it is. We'll be okay. I need to solve for d. And since the cosine of d gives me this relationship, d is equal to the inverse cosine of 214.56 divided by 252. So we can type that into our calculators. Hopefully they're still in degrees from before. And we end up with this being approximately 31.6 degrees. Whew, that was a lot of work. That was a lot of work just to get one of the angles. But we did it. We've got angle D now. Let's go all the way back up. Oh, that's so much work. 31.6. Now we got to find the other two angles. And here we have an option, okay? We have three sides, just like before, and now we have a single angle. So, if I have side, 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 I have to use the law of cosines first, and then I have a choice. Okay? I could do the law of cosines a second time. I could do it a second time to get my second angle, or I could do the law of sines again like we did with the first example. You're going to get the same answers regardless, or it's going to be close because of rounding. And that's what we're going to be going for here, is close. So, in the interest of time, I've already spent 10 minutes on this problem. Let's do the law of sines to get our second angle. So, law of sines again. Give me a moment to erase all the work from before. Alright, now, so we're going to try to find angles E and angle F. And we're going to use the law of sines to get angle E. So I know from the law of sines before, it's the sine of angle D divided by side D is going to be equal to the sine of angle E divided by side E. And unlike when we started off the problem trying to do the law of sines, this time it'll work because I know D and E, and I know angle D. So I can put all that together. I know that it is the sine of 31.6 divided by 6.3, and this is going to be equal to the sine of angle E, which I don't know yet, there's my unknown, divided by 10.5. So there's my setup. And just like we did before, I can now use this proportion to cross multiply and solve. So we are going to cross multiply the top with the bottom to get 10.5 times the sine of 31.6, and we're going to cross multiply 6.3 with the sine of E to get 6.3 times the sine of angle E is equal to 10.5 times the sine of 31.6. Okay, so there's our equation. There's our equation. Now, just like before, we want to get the sine of E all alone, so we're going to divide away 6.3 on both sides. And that gives us the sine of E equals 10.5 times the sine. I know I didn't write the multiplication symbol before. It doesn't make a difference that I did now. all of that divided by 6.3. There's what the sine of EE equals. Remember, this is our relationship. This is our opposite side, the length of our opposite side divided by our hypotenuse. And then we can use inverse sine. So E is equal to the, angle E is equal to the inverse sine of all of this, 10.5 sine of 31.6, all divided by 6.3. That's what we're going to type into our calculator. Just like before, I said you probably want to put that top part in parentheses, and that's going to give us an angle of approximately, since we're rounding now, approximately 60.8 degrees. So we now know that angle E is approximately 60.8 degrees, and we can add that up here, 60.8. And now, finally, just like with the first example, I know 2 of my 3 angles. The easiest one to get is going to be the final angle. Take 180, subtract the angles that we know, and we are going to be able to get the angles that we don't know. So let's do 180 minus 31.6 minus 60.8. That's going to give us capital F. And what are we going to have here? 180 minus 31.6 minus 60.8. We get 87.6. So approximately 87.6 degrees. And all of these are approximate because we had to round all of them. So there we go. I know this video was very long, but hopefully it helps you with some of the law of cosine stuff. If we need to make another video, I can do another one where we can do more examples of side angle side or side side side. But hopefully this demystifies some of it and helps us with law of cosines in the future. Thanks for watching, and good luck.